Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to talk about Clean Code by Robert C. Martin. Talking today about Chapter 11, all about systems. If you guys remember, last time we talked about classes. We talked about how big classes should be. We talked about how classes should be encapsulated. We talked about the single responsibility principle, which was probably like the biggest thing from that last chapter, which basically says classes should really only have one reason to change. In other words, classes should really only do one thing. Very similar tenet that was described earlier in the book when we talked about methods. Methods should really only do one thing. If they're doing multiple things, abstract out those other functionalities from that method into separate methods, and you can do the same thing with your classes. We talked about class cohesion and how that is not necessarily a good thing, and how you can end up breaking stuff up into multiple classes based on how cohesive your class is. So check out that last video for more on classes. That was chapter 10 today. Talking about systems, and Robert opens up this chapter and he talks about this concept or this theory or this little thought experiment about how you would build a city. And it's a good example or a good alliteration or analogy for how to build systems and software development. So he asks you, how would you build a city? And ultimately you build a city with teams, because cities work because there are teams of people building that city, because one person can't do it alone. So how would you build a city? You would modularize and abstract out the processes that you have to do to build a city. And what he says about this is that components, and this is from a software perspective, components can function without knowing what the other ones are doing from a software development perspective, but extrapolate this out to building a city, and it's the same thing. Now, the example I'll use is the people who are building bridges in the city, maybe they don't necessarily have to know how to build the houses of the city or the condos of the city or the townhomes, etc. You can have them both working at the same time without having to know what the other is doing. The people building the houses don't have to know how to build a bridge. They don't have to know the components to build a bridge, but they might use the same components. So the people building the bridge, they're using 2x4s and whatever, scaffolding, or maybe not scaffold, that's the wrong word. I'm not into this construction stuff, but they're using, 2x4s, concrete. Maybe you're using those same components to build a house, but just because you're using the same components doesn't mean you have to interfere with each other, and you're not tightly coupled to each other. So that's ultimately what that thought experiment there is, to get you to think about, how would you build a city? Well, in the same way you would build software, you would have components of your project that don't have to rely on one another. Now, one of these reliances that happens sometimes is object creation from object use. And what Robert Martin talks about in this section, separate constructing a system from using it, is that you should separate out the building of your objects or classes or what have you from the actual use of it. Excuse me. So he says software should separate the startup process from the runtime logic. Sorry, this is a separate type of example, but it's an example of how to separate different components in your app. So if you have a startup process, it should be different from your runtime logic. And oftentimes this gets blurred a little bit when you have lazy loading. Now, the startup process is the first concern. Now, what do I mean by a concern? Because there's separation of concerns, which is a big thing, big concept. I think we talked about that. We talked about that in an earlier video, I think. But a concern is basically a specific aspect or a dimension of a software's functionality. Going back, I think I kind of equate it a little bit to the single responsibility principle, in that classes should only have one reason to change. Classes should really only do one thing. And separation of concerns means that different components are separated based on their functionality, and they're not tightly coupled to one another to the point where they have to deeply rely on one another for your project to run. So the startup process is the first concern that you have to deal with. Now, what oftentimes happens is stuff upon startup is lazily loaded. So yeah, that's the bullet point that I have there. The code for startup is often mixed in with the runtime. And this is often happens when there's lazy loading. Now, what is lazy loading? Lazy loading is the method of construction does not happen unless we actually use the object. So at start time, you can have a method that says, if you could have like a Boolean check, if startup has started, like a has started Boolean, and then you create your services and your repositories and your other POJOs or other class objects upon startup if that Boolean is false, which it usually is because, or if it's true, if has started is true, hey, I'm going to build my service class objects, I'm going to build my repository class objects. Because if you think about it, that's what happens when it's not running, it's false. But once it starts running, you change it to true, everything gets created, which seems like a good idea, right? Seems like a good idea, but it can potentially often lead to some issues, which we're going to talk about the next slide. So this is kind of what I mean by lazy loading. This hobbies list here in the person class, you can see that it's an instance variable. We have this get hobbies method, which is going to construct your list of hobbies if the hobbies is null. And that will happen because this person constructor is a one argument constructor. All it is taking a name. So all you have to do to create a person is just give it this name. And that's what they do down here in this main method. You have a new person named Alice. And that person is not going to have a list of hobbies. So what you do is you call person.getHobbies, and this is going to lazily load hobbies into your list. But this can come with potential issues as it's laid out on this slide. So you could potentially have unwanted dependencies. So unwanted dependencies, and we're going to talk about dependency injection in a couple slides, and what we mean by dependencies is things that depend, right? So something depends on another thing. So in the person class, if I go back, you've got two dependencies. You have a name and hobbies here, right? So you could have unwanted dependencies from lazy loading. So the order of things that have to be called, this is potentially an unwanted dependency on the fact that you need to call things in a certain order. So if something is lazily loaded, what if you call that attribute before it gets lazily loaded? So what if later on in this main method, you say, because you can get the instance variables using getters, or you could say person.name and you'll get the name Alice. But what if you did person.hobbies before this line person.getHobbies, right? You would return a null here. So that's an unwanted dependency on you have to go and load these hobbies before you use a dot notation to get the hobbies. You know what I'm saying? You have to call get hobbies before you access what hobbies that person has. That's the better way to say it. So there could be unwanted dependencies with lazy loading. It could be very much so hard to test as well, because if the loading and the business logic is tightly coupled, then isolating those different cases for testing becomes tougher. Maybe not impossible, but it becomes tougher, and there's just more test cases maybe that you have to cover in that regard. And then as well, there's a violation potentially of the single responsibility principle of classes, and I wrote this here, think about it, if you had a class that initially loaded things and also handled the business logic, that might be doing too much, and what you might need to do is separate this out into multiple classes, one for initially loading things and then another class to handle the business logic of the things that were initially loaded. So one class to lazily load the hobbies and another class to, build a list of hobbies, rank the hobbies in the order of most favorite to least favorite, add more hobbies, etc. So those are the potential issues when you lazily load something and when things are tightly coupled together and when you don't separate construction from using something. So separation of main. So one way to separate construction from the use is this separation of main. So I kind of have an example of this on the other slide where you don't have a ton of business logic in your main method. And this is like if we're talking about, I don't know if there's a main method in other programming languages, but definitely in Java, you don't want to have just a bunch of logic in your main. Because think about it, if you wanted to, you could include, repository stuff, database stuff, everything, Pojo's like right there in your main method. But what this is saying, separate all that out, move all aspects of construction outside of it, or move it to a main module, and then only use the main method for using that stuff. So you decouple the building from the object. And that's really the goal here, what he was saying in this section. Essentially just separate construction from the actual use of the thing. And I have an example of this on here. You have this shape calculator class. You can calculate circle area, but this is defined in another class, and then you use it in the main. So you don't have to have this calculate circle area. You don't have to be doing this calculation here in the main method. You abstract it out, and then you encapsulate it maybe in the shape calculator class. And then you call that, hey, shape calculator.calculate circle area, calculate rectangle area. That's kind of what he means by separation of main. So factories, this next section, this is talking about, there's a pattern in Java called the factory pattern, which is basically used for dictating when an object gets created. And it's good for encapsulating the behavior of object creation. So it gives an application control on when to build an object without actually showing how the project gets built. So it essentially creates a method that you can call that'll just automatically create the object that you want without exposing, the fact that you're using a new keyword out there like in your code for like the customer to see, and you can encapsulate that and hide that away. So it provides some benefits. Creation details, like I said, they're encapsulated. Customers don't need to know how stuff created. They just care that it is created. It also makes your code a little bit more flexible because if you need to change something, you change it just in the factory, and you don't have to go in multiple places in your code where you're using potentially the new keyword, and you don't have to just change things in like 10, 20 different spots. You just change it in the factory class or interface that you have, and boom, all the rest of the code changes with it. So here's an example of this. You have an interface vehicle. You have a car that implements vehicle, so it's going to have that start method. And then you have this factory interface down here, vehicle factory, vehicle create vehicle. So you know that it's returning a vehicle. You know that motorcycle and car are types of vehicles. And you can then even create concrete factories from this that implement the vehicle factory. And look at this. You can create this vehicle and return a new car. Right? So in your code, you would call this create vehicle method, right? You would call this create vehicle method to return a new car. And you wouldn't have to actually do car1 equals new car with this amount of attributes. You can customize it here. You could create cars with different types of attributes, and you can hide this implementation here. Or you can just create a car of one type, or you could customize it to where you're getting the customer to create cars based on, the constructors, or excuse me, not the constructors, but the arguments maybe that you pass into this create vehicle. Maybe you're taking in two arguments, a string color and an integer number of wheels, etc. So that's kind of the factory pattern, making your code just a lot more flexible in that regard. And now we get to dependency injection. And we talked about dependencies. Dependencies, you depend. So classes depend on their variables. And injection kind of meaning that the variables are going to be inserted into the class externally. Dependency injection is an implementation of inversion of control, which is a principle in software development, and this comes straight from the book, where you move secondary responsibilities from an object to other objects that are dedicated to the purpose. So in other words, other components are going to provide the dependencies that a class will use. And like I said there, dependency injection is an implementation of an inversion of control. So think of those words, inversion of control. The control of the class's instance variables is going to be controlled by something else. So you're giving that control to somebody else. You're inverting that control. So like I say in that second bullet point, objects should not take responsibility for instantiating dependencies upon itself. This can potentially run into issues. What you want to do instead is pass this responsibility to other classes or things. So instead of a class creating its own dependencies, they are provided externally. I'm going to have an example of this on the next slide. And then what you can do, or how you can do this, is you can provide setter methods or constructor arguments to inject dependencies. Just like nothing new, we've seen this before with the new keyword and using that to create objects. You inject those arguments into that constructor. So you know how on the earlier slide we had a person class, right? And they had a single argument constructor of name, and you just pass it in that name, a string Chris. You're going to do the same thing here with dependency injection. So the DI container instantiates the objects, and dependencies are then wired together. Here's an example of that on the next slide. We have a user service class. This is Java straight from, this is Spring with the annotations. And then we have a repository class that implements a user repository. Now, this user service class has a dependency. It has the dependency on the user repository. That's an instance variable here. And then we are using constructor injection to instantiate the user service class. It's taking in a user repository, right? This is the dependency injection at work here. So it's going to rely on you to inject this dependency into user service. It's not creating this user repository on its own. It's taking it in because, right, this is a constructor. This is a method. It's taking in one argument. It's going to rely on you when you use this to assign it to the user repository instance variable here. So it's not creating this on its own. It's relying on you to do it. And in this main method, you can see here, this is nothing new. We've seen this before, guys. The user service object here is being created using the new keyword and the user repository that you pass in. And that's dependency injection. You're passing in this user repository, which you created using the new keyword. That doesn't have any dependencies that you need to inject. It's got a users list instance variable, but it doesn't have a constructor. You just create it like this, and then you inject that into user services. And then you can use user service later. This is bad. So this is, I just typed into ChatGPT, like, like if you weren't using dependency injection, how would you do this? How would you duplicate that same code? And what you would do, this is the main thing right here with this comment, constructor-based hard-coded dependency management. This is bad. Don't do this. The user repository is just created based on your creation of the user service class. So the control is given to user service to create an instance of user repository. You're not in control now. User service is in control. And when that happens, bad things could potentially happen because now this is tightly coupled. So now if you make a change to user repository for some reason, and maybe all of a sudden user repository has some arguments, like multiple constructor arguments, maybe you don't allow a default or no argument constructor. Now all of a sudden you got to come into user service and you got to change this, right? You got to change this. This is a no argument constructor here, but it's not allowed anymore. So potentially it could cause issues, and this is a little bit too tightly coupled. Dependency injection is probably a little bit better of a pattern or a thing that you use, that you should use. So we don't want our cities to stay the same. What if the cities get bigger? Well, this eventually happens because maybe you don't build a city at first. Maybe you just build a town. And that town could eventually grow into larger towns and larger cities, right? So Robert says in this section, we can't get things right the first time. We can try, but we just can't do it sometimes. And what we instead need to do is, yes, it's important to plan for the future. It is, but if you build your system correctly, it's going to allow for you to expand. So rather than being super, super specific and nitty gritty in the details to begin with, be maybe a little bit more general, but allow for system change. So focus on the stories needed today. New stories are going to be created tomorrow. And software architecture can grow incrementally if we maintain separation of concerns, if we maintain an environment where other components don't care what other components do and things aren't tightly coupled. That's going to allow those towns to grow into large cities. But if all of a sudden, I don't know, you have the same people working on the bridge building as the same people working on the townhomes, then all of a sudden there's a dependency on that front. And all of a sudden there's not a separation concerns, and all of a sudden things just take a lot longer. And all of a sudden you got to manage, this guy's working over here, but he's got to work over here starting at 8 o'clock, and turns into maybe a little bit more of a hassle, a little bit more of a mess. So that's kind of what he meant by scaling up. So cross-cutting concerns. So concerns, remember what was the definition we talked about earlier from a concern? A concern is basically the functionality of a component within your project, right? Oh gosh, this is going to be annoying, but I'm going to go back because I want to read that definition I had of concern. I'm sorry, guys. Because I really liked that definition that I had. I think it was, yes. So a concern, a specific aspect or dimension of a software's functionality. A specific aspect or dimension of a software's functionality. Basically, just think of a concern as like the functionality. A concern could be like a class. Like the class does one thing, that's a concern. I guess that's how I'm going to think about it. So sorry, I just wanted to get that definition right for you guys. Scaling up. Cross-cutting concerns. There we go. So concerns can sometimes cut across natural object boundaries of a domain. So essentially, you can have things that get utilized in different files and different classes across your project. They cut across different modules and components. So they affect multiple parts of the database. Now, everything we've learned so far, single responsibility, inversion of control, dependency injection, et cetera, and again, more so the SRP, the SR principle, that classes should only have one reason to change. They should really only do one thing. This can potentially be a problem because potentially things are being used, multiplied in multiple places throughout your code base, and maybe your class is going to end up doing more than one thing because of that. It could potentially be a violation of the single responsibility principle, but how you can handle it is by using aspect-oriented programming, AOP, and this was something that always confused me about Spring because Spring has like when you go to Spring Boot and you initialize a Spring project, there was always like something called aspect. I never understood what that meant. But now I kind of do. And aspect-oriented programming is basically where you cut down on the duplication of code by creating these aspects. And aspects are modules that encapsulate a cross-cutting concern. So when you have something that's utilized in multiple areas of your project, you create an aspect for it. and it encapsulates the behavior in the aspect and then allows you to use the aspect instead of that actual thing. And a very common way this is done is, or a very common cross-cutting concern, I guess, is logging. So yeah, right there. So in OOP, concerns might spread. Lots of code duplication. In AOP, concerns are separated, leading to modularity. That's kind of the goal here. So in logging, this is common. So oftentimes you can have like a logger, like log4j is, I forget what package. Is that Apache? I think that's Apache, log4j. So you bring that into like multiple different files because you want to log out, you want to log.info, you want to log.error, certain things. Okay, that's cool. But you see you have cross-cutting concerns now in multiple areas of your project. If you log out stuff in your user service, you log out stuff in your user repository, you log out stuff in your user mapper, and etc. What if that logger changes? Now you got to change it in multiple different areas of your project. So on the right here, you create an aspect called logging aspect, and you can now execute this method when stuff gets logged out. And I'm guessing that this would get called when you print stuff out. So it would say creating user such and such, logging method such and such. Like this would be appended, or this would be like called before this creating user method. This would be called before the updating user method. So now if stuff, God forbid, stuff changes to your logger or what have you, you just change it in this spot. You don't have to go and change it here and anywhere else in your code. That's the advantage of using aspect-oriented programming, and there's ways to achieve that, that are talked about in the book. There are these things called Java proxies. These are for simple situations where you wrap method calls in individual objects or classes. You can intercept method invocations and add something to them. This is kind of a little bit what's done on the previous slide, where this print statement is going to be called, before the execution of this print statement. So that's where Java proxies can be useful. You can also use pure Java AOP frameworks like Spring. Oh, that's what it was, Spring AOP, which utilizes, you can write POJOs, plain old Java objects. We're going to talk about that in a second. There's other frameworks like AspectJ, JBoss AOP. So there's ways to achieve aspect-oriented programming in your code, different avenues depending on your situation. So I think this was an example of the proxy. Yes, so user service class, user service implementation, that's implementing the create user and update user. On the right, we have a proxy. We have a proxy that's taking in a user service, which is going to be the target. So when this gets created, when that gets created, this gets invoked whenever you call these create user and update user methods from the user service. So essentially, and I guess in a way here, you're using dependency injection. You're injecting this user service implementation into your proxy. And now, anytime you call create user or update user, these print statements are going to be invoked before and after, I'm guessing, this print statement gets executed. So you'll have logging before. So when you say, proxy service.create user Alice, this is going to get logging before invoking method. Then this is going to get invoked, creating user Alice, and then logging after invoking method. That's kind of like the order of operations there that's going to happen. And then this is an Spring AOP example using the annotations. You can see here, no annotations, very manual, but still works. This is Java proxies. And then in here in Spring, you actually have like this aspect annotation, which you can use to create your aspects. And then you can have these method invocations for before and after, certain methods get invoked. And I'm guessing that's what would happen here when you say create user or when you say update user. So that's a Spring AOP example. Next up, test driving your system architecture. So decoupling using POJOs. So this was something we mentioned earlier. POJOs, plain old Java objects. So these are essentially like a class, like a user class. Basically, the minimal divisible unit that is being operated on by your service and repository. Sounds very complicated. I'm probably complicated using that definition. What do I mean by that? You have a user service, you have a user repository. Okay. I would assume you have those two classes operating on users. Users in that case would be your POJO. They're going to be the things that are operated on or that you change, that you add to your database, that you take out of your database, etc. And these things make your project more aspect-oriented and reduce cutting of concerns. Makes the objects independent so you can use them throughout your project. And they come in handy a lot so that you can just change whatever user that, I don't want to say user that you're using, but you just have to make changes in that one spot in your user class. Like all of a sudden, okay, your users are going to have an email. You just change it in the user POJO so that you can then utilize it in other areas in your code. And then in this section, Robert talked about BDUF, which is big design up front, which makes it harder to make radical changes later. And this kind of ties to the previous slide that we were on, talking about trying not to get things right in the very beginning, instead trying to just get the architecture right and separating concerns and making your project modularized to make it a little more flexible to make changes later. And he's basically saying this big design up front is not the best idea because when you make a big design up front, maybe things get too tightly coupled and then it makes it hard to change things later. But when concerns are separated, you don't need to huge planning up front. It just allows for the changes later as long as you get the system right, the architecture right. So plan on being flexible in your architecture, but don't necessarily plan for these big sweeping changes, concrete changes especially, because it's going to make things harder to change later. I was wondering, we still need some planning. Any APIs in use should largely disappear from view. Very true. We talked about that in a previous chapter, how you should hide the implementation of the API and then use the implementation rather than the API itself. I think we kind of used, it's not an API, but we used the example of a hash map where instead of just using hash map directly, maybe have your own hash map class where then if anything changes, you just change the hash map class you created instead of just changing all the places in your code where you're using the hash map, etc. So how do we optimize for decision making? That's a good question. So give responsibilities to the most qualified people. So when you're building a city, who's going to build the bridges? The people that are most qualified to build the bridges. People who have the most experience in that regard. And yeah, is it good to have some people learning on the job? That's kind of what I do sometimes. Yeah, sure. But for the most part, you want the people in charge of that thing who have the most experience and are the most qualified. He also talks about here postponing decisions until the last possible moment. Premature decisions are made without proper knowledge. I totally get what he's saying. I do kind of like, though, getting out in front of things and making decisions early on so that it can kind of just move you forward and get the ball rolling, because I know sometimes people hesitate in making decisions. I don't think he's talking here about hesitating necessarily. It's just postponing until you have all the right knowledge. And listen, even when people have all the right knowledge, they can still hesitate. And I don't think that's a very good thing either. He's just advocating, hey, make sure you have all the knowledge at your fingertips before you make a decision. And POJOs are going to allow for just-in-time decisions because of modularity. Next up, Use standards wisely when they add demonstrable value. Don't let it come at a cost to delivering things on time and great software. I guess he's talking here about just don't be too rigid. Like, don't just like, oh, we're only going to do it this way, because then maybe that might compromise some flexibility in your team. And then next, systems need domain-specific languages. This reveals the intent of the code, and it bridges the gap between concept and the code that implements it. What does he mean by that? I don't know exactly what he means by that, actually, but he means something like you should have code that kind of outlines your plan for what you want your classes, methods, etc. to look like, because this is domain-specific language right here. So you look at this, you have a recipe chocolate cake, you have ingredients, and then you have steps. So here, if I'm making an app that involves, I don't know, like a cake decoration map maybe, or a cake recipe map, I'm already thinking like, okay, I have a cake class, right? And maybe that class is abstract because cakes are going to have, no matter what the type of cake, it's going to have similar attributes, whether it's chocolate, vanilla, Oreo, peanut butter, tuxedo, what have you. So I'm going to make an abstract class, and then I can have concrete classes that extend that class, and then they have their own attributes such as flavor, such as color, etc. These are the ingredients. So maybe ingredients is another different instance variable that's going to depend on the type of cake. And then these steps could be like your methods, like you have a preheat method, you have a combine method, you have a baking method, etc., etc. So a DSL, a domain-specific language, is essentially like your plan. This is how I look at it. It's the word, or like the English language description of how your project is going to be set up. And you can look at it and break it up into, like I said, classes, variables, steps become methods, etc. So, in conclusion, systems got to be clean. When domain logic gets obscured, quality suffers. If agility is compromised, then productivity suffers. And then POJOs plus aspect-oriented programming like mechanisms to address concerns, specifically address cross-cutting concerns. And ultimately, guys, just keep it simple. KISS. Keep it simple, stupid. Use the simplest thing. And guys, that's going to do it for Chapter 11 from Clean Code. Tune in next time. We're going to be talking, what are we going to be talking about next time? What are we going to be talking about next time? We're going to be talking about emergence. This is interesting. I don't know what that means, but we're going to find out next time. Thank you guys so much. I know this was a long one. Hopefully everything was clear. Let me know if you have any questions in the comments. I did my best with this, with the descriptions and the examples. I actually was recording this, and then I stopped because I didn't like the way that I was recording. I had to go back and fine-tune my definitions and my understanding of DI and IOC, SOC, etc. So hopefully you guys liked it. Let me know. Check out the podcast. Guys, thank you so much. Over 700 subscribers. Thanks for sticking with me. Big things coming always. Thank you guys so much. This has been Chee-Tash. Take care.